let's talk about how we can actually solve these things with the tooling that we're all experts in here, right? So CI can't just be uh, the thing that runs your tests and says good, now hand it off to a human. It has to be better than that. So it has to be able to provide all of this feedback loop to the contributor, whether that's an agent or a person, before you actually get a maintainer reviewing it. Because again, that's at least our theory and our take from talking with a lot of people in the field is that this is the bottleneck for these teams is getting maintainers to like look at things, know that it's good to accept and merge. So you have to get this feedback loop with the contributors really early on before maintainers even need to step in the loop. So we're
And
talking
in
about
your own team, probably, right? In your own team,
exactly.
maybe even if you don't have a huge open source project, if you have like an internal, team, you're probably one of those reviewers, one of those maintainers. You may well be. So like, we've got all these different hats. Like I'm a son and a brother and a father and a whatever, but I'm also like a developer and a DevOps person and and a maintainer and a code reviewer, so it's like now I've got to like, switch over here and like review a bunch of code when I need my own code reviewed and I need to be improving the pipeline and,
Yeah. And so that
crazy.
this isn't just, adding an LLM into the loop that does a code review first and then you're good, right? That might be part of it, but that's not the solution. So we're talking about bringing the right tools and more advanced tools to the development process. So that we talked about all that the human linting and human style editors. We need to take it back and say, like, I've had so many pull requests, and I'm very guilty of this, where every like little lines are nitpicked of like, oh, it should be, in this part of the org, we write it like this and not that. And so we need to codify those things so that your linter, if your linter today isn't advanced enough, it needs to be, right. We need to get to this point where like, all right, if this style isn't caught by your tooling, it's not actually your style. Okay. So that's both like writing styles for docs and code styles, right? Your linter needs to be better. So that brings that feedback loop earlier in the process. And that's something that agents can use directly when they're writing the code, right? So they're not giving you a bunch of bad code that then needs to be fixed. Rules and docs, like I talked a little bit about that developer documentation. To kind of bootstrap this process, you need to start with something for your developer documentation. And this isn't creating like your doc cursor rules file that has your whole project architecture, because that's just for your agents. You need to create something for all contributors, agents included. And so I'm going to demo in a little bit here, but like this is a big part of it, is having this knowledge base of how to contribute to the project, and not just having that thing exist and you created it today and it's going to sit there for 5 years. It's something that if something comes up in a review that isn't documented there, it needs to be added as part of that review process, right? It's not just like, oh, I read this thing, oh, that's out of date, don't worry about that, we actually use this tool now, right? It needs to be continuously updated. And then on the agent side, if it's out of scope of the developer documentation, the rules need to be continuously updated, right? So if I'm reviewing Jeremy's PR and he's writing some Go code, and I say, oh, actually, Jeremy, we don't use panic. You have to return errors everywhere. Now, Jeremy knows for all future PRs, and he might forget sometimes, and that's okay, but he knows in general, like as he's writing code, oh, I need to make sure to return errors and not panic. If I give that review to an agent and say, oh, actually, Claude, we don't panic, we return errors, it's going to be it's going to say cool, it's going to fix it, and I'm going to have to tell it that every single time. So that's the kind of thing that you need to, when you see that in a review, it needs to be codified in the rules or developer documentation for all contributors so that it carries forward, right?
Yeah, that workflow of making sure that you have stuff documented for the AI is probably something that if we fast forward a couple of years, like it's probably going to be one of the first things we all do. I think those of us that have been on GitHub for 15 years, like at least for me, one of the first things I do when I create a repo is I make the README. I'm a jerk about READMEs. Like if people don't have a good README, I give them a hard time, right? But to me, the rules, regardless of where the file goes, because like we haven't really standardized on where does the AI rules go, and where do we
Yep.
trust it, and is it per repo? Is it in your is it in your documentation, or is it in the repo itself? There's all these different scenarios, but I think the bottom line is like having a lot of your assumptions and a lot of your the things that you just know in your team. Well, we prefer this particular linter, and we prefer this particular style of something, particularly on older languages. I think that where there's a lot of different branches of different styles and you have different opinions, it's pretty important to put all that stuff in there. I just wanted to ask you a question real quick. Like, as we're covering all this, Jim had a great question in chat. He asked about if, like, trying to look at this overview of where are we going. I don't see a near-term future, and I'm curious y'all's opinion. I don't see a near-term future where we are letting an AI automate in a traditional, let's just say GitHub Actions or wherever we're running our CI.
Yep.
But I don't see a near future where we are writing an issue and just saying, here's my problem, I want an AI to fix it. And then an AI goes and writes it, reviews it, approves it, tests it, writes the documentation for it, and does every single possible thing, and then automatically deploys it for me. Like, this is a baby step scenario.
Yeah.
I feel like we were all doing the same thing a decade ago with containers. We were trying to keep people from boiling the ocean with containers on their first month in Docker land. And now here we are in AI land, and it's like, okay, I think we're all going to move slow, and we're all going to try one thing and see if it works. And there's a big question around what's the first thing in CI that you're going to add AI to? Like, what's the team's pain point that we really wish we had another human to do that? And that might be a good place to start, where if you have a human review or a human that has QA or certain oversight, or someone has to check the test coverage percentages and then fix that part because maybe someone in your team is not good at writing tests, and that you just can't beat them over the head enough with testing, so you have to write some for them. Like, maybe there's something like that you have that's a problem that you want to approach first, but you don't want to just throw AI everywhere and then hope for the best. And not that Jim was suggesting that, but I think it is for me at least at the very beginning of the year, it was a big, real question around, where do I start? Like, I know how to use it in my IDE. That's pretty prescriptive. We all get an IDE. It has an AI agent or something in there that we can engage with the LLM. And that workflow didn't really need a lot of instruction. We all kind of figured it out pretty quickly. But I think in CI, it's this big open, in our automation platforms, there's just a big mess of everything. We do all sorts of stuff there. We build images, we test things, we push things around, we take images from over there and put them over there for the production cluster, and we automatically deploy things into staging, but not into production. And we have a mess, right? It's just a giant ball of automation. And looking at that and thinking, how do we unwind some of this and stick some more automation with an LLM in there? It can be, we don't really have like an industry top 5 yet. So I was just curious what are you seeing? What are you trying that is like maybe the first steps that people are trying? Is there anything that's just wild, wild west and maybe we don't do that
even
yet?
Show some of that, probably.
Yeah. We'll
close.
definitely touch on a lot of that. I think there's a lot of layers to it. First, as we unwind that, I think it's incredible that we ship anything today at all, right?
Right.
Second, the technology is changing so fast, and we're excited about it. So we very quickly think about what can it do tomorrow, right? And as people that are super excited about it, we might say, oh yeah, we'll just hook it up to Jira and it's gonna start shipping stuff,
right? Just tell it all of our tickets open, and
exactly.
It'll PR every one of them. Yeah.
We're living in a sci-fi world in our minds, and we need to connect that to reality for these real organizations, right? But yeah, I think it's starting small. It's very incremental. So it's can we get those review cycles in before a human needs to review it? Because a lot of times, like we talked about, those style changes, right? If we have better style, linting tooling, and we can get those iterations through for the contributor, instead of having the back and forth 20 different times with a maintainer, then that's saving the reviewer's time, so that way when they look at a PR, it's in a much different state than it is today. So when they look at it, it's according to all of our tooling, which is much more advanced than it was yesterday. It's mergeable, and they can look at the things they really want to look at. They're not going through this huge checklist of okay, did the person write tests? Did they write docs? Are the tests even passing? the style, like all those things we talked
That's
about.
all like a given. Yeah, because it's
Right.
been
So we can throw that out, and now the person
Yeah.
shows up and they say, I can trust that this is in a pretty good state now. I can look at a much more refined set of things.
So yeah,
So
you
that's
shorten the
hope,
review.
right?
You shorten the human review. Yeah, I like
Exactly.
it.
So by reducing that bottleneck, we can hopefully ship more things. And I think that part will probably still continue to be the bottleneck because we can generate as much code as we want, as long as we're paying enough money for those APIs.
Yeah.
But
I like your scenario of like we've all filled out the public GitHub issue that has a template that has a list of checkboxes of things we don't want to do. Right.
Yeah.
When I submit the issue and I'm like, this is not working. I don't know how to fix it, but I'll give it a shot. I also don't want to figure out how they build their documentation and what markdown style they have, and also like what test framework they're picking out. I mean, maybe some of that stuff, but I feel like that just means it's less likely that I'm ever going to submit a PR because there's just this litany of tests and agreement. I have to agree to the code of conduct. I have to agree to the license. I have to sign this thing. I have to do all these things, and some of those things are not optional, but some of them people submit a PR, and now that's maintainer's problem, and maintainer has to go, well, do I want to do part of their work, or do I want to push it back to them in the likelihood that, especially in open source, that they may just like there was a one shot from their point of view and they're not going to come back and fix this, which means I have to decide, do I throw this PR away, or do I do their work and finish it for them in order to get this PR through? That feels like less. Like I always think of these AIs and CIs in terms of risk. Like what's the worst case scenario? And in that case, the worst case scenario is the PR would have been dropped anyway. It's probably not going to get done if the AI can't help us to get it over the finish line. Maybe it won't happen anyway, but it wasn't going to happen before. So to me, it's like it's like a lower risk scenario if you do that. And you're not saying replace a human with AI. You're just saying shorten that window, give it a little bit of assurance. It's almost like giving a junior dev the first round of review before the senior dev reviews it to accept.
Yeah, we're shifting CI left, right? We're moving a lot of the stuff that we're doing manually today into automated tooling. And yeah, go ahead, Jeremy.
And I wouldn't say it's not even giving the junior dev a chance. It's more like taking the distilled wisdom of the senior devs and making that available early in the cycle and to all. I mean, you know what I mean? Versus like you say, oh yeah, let them take a crack at it. You know, and instead it's like saying, no, here is the sacred text, like the distilled wisdom of the ages, and we will use that, you know, as the first pass on everything before it even gets to the council, you know, of elders. So
right.
Yeah. I don't know. I'm excited. The other thing I think that maybe for folks to keep in mind and about this kind of like the back and forth piece, like, can we just like, you know, can I just give a prompt and get a thing back? You know, can I just give a prompt and say, build me the Death Star, and it'll build the Death Star? Well, as we know, a lot of these problems need to be broken down, just like we break them down in software engineering today. And that by building machines, architectures that have different stages, that some of them are agentic, some of them are not, some of them, you know, generative or not. And by putting those together, composing those in the right ways, you can get better results. And so I think that's part of what we'll see is the reason why just getting back like CI failed or passed and getting the logs output is probably not going to be sufficient for actually making your CI work. And so I don't know, Kyle, what do you think about?
Yeah, I can take it away. And I want to emphasize too, like a lot of the things when I think about agentic CI, it's not building better coding agents that produce more reliable code. It's actually building a better CI system, and in some places of it using agentic capabilities, but it's building a better system for all contributors. Okay, so it's not just helping AI agents ship more code; it's helping all of your contributors ship more code, and especially on the review and CI/CD side of things, helping get that code through for all contributors. So that's what we're going to look at with this demo I have here, and it's with my Greetings API project. That's a Go backend and a little front end that returns greetings. We're not actually going to run it. Probably, maybe we will. We'll see. But the main thing is, it's a toy project to kind of show these principles that I'm trying to describe. And then we can talk about like how that's actually implemented and scale that out to the most complex project in your organization. So this is the project, and we start out with, what agents do I have in this project today? And there's a bunch, and they're all doing different things. They have their own roles in the project. We have a developer agent. This is like my coding agent that I can ask it to complete a task for from like a GitHub issue or whatever, and it can solve that task to the best of its abilities. And this is something that uh, that I can iterate on and improve. But this is the thing that I'm using to help generate code hands-free. So I'm also using other agents that I'm pairing with locally when I'm developing features. But we also have these hands-free background agents that are also developing tasks. And so that's the first agent that's probably the most familiar to something that you might be working with today. And then the reviewer agent, and this thing is exactly what it sounds like. It reviews pull requests. But we'll look at how it does that, because that's a really important part of this feedback loop. And the debugger agent, which is something we didn't actually talk about yet in this process, but we'll see it in action. But the point is, when you're linting and tests fail on a pull request, these frameworks these days are so good that they can tell you exactly what's wrong with it. So why not just fix it, right? So this is what this debugger agent does, is it'll take linting failures and test failures and give you the fix. And that way you're not pushing code, watching CI fail, reading logs, making like the one YAML spacing change that you forgot to make locally, and then pushing that up and waiting to see what the next linting issue is. This will actually just fix it for you, because you don't need to spend your time as a contributor going through these loops of just fixing dumb linting things where the logs literally say what the fix is. Like, just fix it, please. So that's what this is. And then the feedback agent is basically an extension of our coding agent that lets us iterate on pull requests with it. So if it's open to pull request, we can give it feedback, and it has the ability to not just take in its original assignment, but also the work it's done so far and what our feedback is. So that's important for this loop that we're going to show. So the first thing we talked about for bootstrapping Agentic CI is developer documentation, right? So a lot of projects have this contributing markdown file, and like I said, it usually might say something like, you need to install Go, and here's how you run tests, and best of luck to you. And for the most part, like, that's kind of where I started with this, is it says, here's how you run the tests, here's your dependencies, and then I've added something that says, here's the layout of the project and where the different components are. And so this is kind of our basic starting point, but this is something you want to like evolve over time, and we'll see how that works in this demo. But this shows like, all right, I've got my Go files. This is the backend server. I've got my docs here. I've got the developer docs here. The front end website is over here, and then here's the Dagger stuff for CI/CD. Cool. So now, as a
By the way, do you
Yeah.
know if the AI knows how to read the ASCII text there? I mean, it actually probably does.
It's
but
good because
cool
yeah,
things.
like I've found like tree outputs can be okay. Even better is like the file list where you get the full path of every file.
Oh, right. Yeah.
Like a
Because then
find
it can just
output.
like literally just look at that path and understand it. But this is great because that they usually get it, and if not, like, they have their own tools to do the file list and they can map it together, right?
Right.
But this
Yeah,
is
I've just
good for
never
humans
never
too.
thought of putting this in a repo to help the AI, because you always see like in dev they always do like they do an LS, and then
Yep.
they're sort of like using shell tools to figure it all out. But this is like that shortcut. That's pretty cool little hack right there. So tip number one.
Tip number one, because this is like literally any agent you pull off the shelf today and start working on a feature, the first thing it's going to do is explore your project. And so the first 10,000 tokens you're using every task is to figure out what is the layout of the project. Now, if you can have better developer documentation, you're going to save a lot of tokens every single run, because you're going to say, all right, here's the map. I'm giving you a map to start with. You don't have to go learn this every single time. And so this is like, again, fairly basic. There's a lot of teams already doing this today, but this is like table stakes number one. You got to make the map. And you have to describe, okay, my backend is Go. It uses these frameworks. Here's some endpoints, and same with the front end. And then here's how you run tests. And so I have this super basic starting point for developer documentation. And again, this is something that both my agents can use, but also my humans.
And shameless plug, you are using
Yeah.
Dagger here, so it will run the
Exactly.
same for a developer who wanders by, or when you run the CI, which is cool.
Yes. And yeah, we'll see that happen here too. And all the agents in this one I've built with Dagger, but like I mentioned, locally I'm using this with other agents like Warp and stuff as well. And we'll see that actually in some of these contributions. So the
Love
agent
Warp.
prompt or
Sorry.
the new agent mode has been a game changer for me. It's super awesome. And yeah, it's a great flow. So here's the developer agents prompt, right? And so we tell it about the problem solving process. There's tons of papers and resources out there for how to write good prompts. I've skimmed most of them, so this is pretty good, probably. But we tell it about the problem solving process. And the first thing is like, look at the project. And so here we're telling it like, okay, by the way, there's this contributing markdown and this heading project architecture where you can read about the map of the thing. So we're not making sure that it can guess to go look in that developer documentation. We're telling it important things to look at. And so as we expand this documentation, I will add references to points in that documentation of things that it should definitely go look at when it's starting a task. And so that way, yeah, we're not making sure that it just figures out, oh, there's docs out there, go read them. We're pointing, and we're not saying load this whole developer documentation into your context. We want to point to specific things and say these are important for solving every task. And the rest of the prompt is pretty boilerplate. We tell it, make sure you're running tests on all these things. And because I've built this in Dagger, I'm able to easily give it my Daggerized test functions and linting functions to run as it's completing its task. And we can look at that code because it's really neat. And then on the reviewer side, and this is something that should probably exist for most teams, even if AI didn't exist, but for some reason it doesn't. But this is like, what are your PR review criteria? Like, what is the checklist that when you show up to a PR that you go through? Because right now, pretty much any project I've worked on, it's kind of like whatever the mood of the reviewer is. Like everyone has their own code review style. Some people look for like little details, and some people look at like, is it solving the problem? Cool, ship it, right? So this is something that most teams should have, regardless of like your codified thing of like, what is the checklist? And so here's our good pull request criteria that the reviewer agent has. And these are all basically the same things we had in that slide earlier. Like, make sure it's accomplishing the task and not adding anything unrelated. It shouldn't be obviously malicious. That's pretty ambiguous. Maybe we can improve upon that and how we think about that problem. We New functionality should have tests created for it, and then these are the important feedback loop things that we talked about. Is like changes to the architecture should update the developer docs. Changes to the product functionality should be reflected in the product docs, and then make sure that it's not going to blow up if we send random strings to it, right? So
And Kyle,
yeah.
I'm sorry, I know you're going to get into some more. It's like tools as a thing, but I think you make a really, really compelling point there that, when you say something you tell an LLM, hey, the code should not be malicious, or if you tell, anyone on your team that, like, there's going to be vast differences in knowledge, experience of people knowing like which tools to grab and try and throw at, throw at a change to see if it could be malicious, right? And it's just, but then if you are able to take that and codify it into maybe a set of tools that, if executed in the right sequence, will give you the right answer, like almost all the time, that's hugely valuable, right? So like striving towards that is probably where we all want to go.
For sure. And I think like writing prompts, like we've all become very great novices at prompt writing over the last couple of years, right? And the biggest takeaway for me about writing prompts is think of every line of your prompt as like a potential monkey's paw. If everyone's familiar with that with that phrase. Do you want to describe what I'm describing, Jeremy?
Absolutely. Like you wish for something that sounds good, but ends up being terrible.
Exactly.
Side effects, unintended consequences, trade-offs you wouldn't have made if you knew.
Yeah, because it's, you know, the LLMs do not know your intent as the writer, like a human would. If I say the code shouldn't be obviously malicious, or the code should not. This is actually a really good one to think about. Like LLMs can, depending on the model, especially, can take things super literally. Where if I'm reading this as a human and it says code should not include changes unrelated to the description, I know, like, okay, it should solve the task and do nothing else. But the phrasing of this is in such a way that an LLM could say, okay, the code should be the description, and if it changes a test, then the description didn't describe tests. And now down here we're saying make sure you change tests, and now we have a logical loop where I can't I can't complete my review task, right? So
Yeah.
like this is basic prompting stuff. LLMs are dumb, they're getting smarter, but you have to make your prompts unambiguous.
You're like, this is actually not obviously malicious. It's quite a nice subtle kind of balance.
Right,
But,
exactly.
we're gonna let that in. That's good.
Yes,
I like that.
that's a great point right there.
I was going to ask you if you know whether or not the AI is, and speaking to the statement obvious, like like it makes malicious conditional.
Exactly.
Have you noticed whether positive or negative? Like, in other words, a lot of these are you should not include. Does it work better in the affirmative, where we say something like the code should include changes only on the description or something like that instead of the negative? This is just taking me back to my wife always telling me the positive thinking, and that if I think about something in the negative, I'm still thinking about it in the positive. Anyway, I just wondered if the AI had any susceptible, because if you take out that word "not," suddenly that sentence is complete, like one word completely changes the definition,
Right.
the whole sentence.
If that word gets dropped from the context window, and now we're only writing malicious code.
Yeah. I'm like doing a search on archive.org right now to see if I can find a paper that addresses it.
I'm sure I personally don't know either way, but I'm sure there's a better, like a correct answer to that. I'm sure there is.
Yeah.
So lots of really interesting things to think about for prompting, but this is something that's generalized to all of agentic anything, right? Okay, so let's look at the first contribution. And this is from a very naive human, myself, in this scenario. And I thought up a great feature for the Greetings API, which is to add farewells to the API. So now it can say goodbye in all these different languages. And like any good contributor, I have added my endpoint, and that is it. I didn't add or update tests. I didn't add docs. I didn't do anything. And so as you know, if I was on a team with this person and this is just the way things go, I might say, hey, try to add tests, and maybe you go back and forth a few times, and then eventually I say, whatever, I'll just add tests later, right? But if we build in tooling around this, then all of that conversation can happen without me, right? I am building an agent reviewer and all these other tools to help this happen before I actually show up to this PR to review it. And so I've done these things. I use, and this was with like my local agent, so I use Warp and container use to build this thing in a little sandbox and then push it up. And then we get this little comment that tells anyone looking at this PR how to run this PR locally. Again, this is like a cool thing you can do with Dagger, since you can run any code wherever it happens to be. I can just run this on my machine without even checking out the repo, and I can run the test for this PR, and I can run the full stack to like look at it if I'm making changes. So this part's not agentic at all. It's just a cool thing that you should totally do, because preview environments are great, but like if I want to actually run the tests on a PR, that's kind of more complicated usually. So we have our first agent has entered the chat here, and I didn't update the tests. One of the tests was failing. If we go up here, we have this little red X that says our CI failed. And so the test failed and because I didn't update the name of this function, I guess, and the debugger agent is able to say this will fix it, and as the contributor, I can just hit if that looks like the right fix for this. I'm like, oh yeah, I should have updated that. Then I can just hit commit, and now it's fixed on my branch, right? So I don't have to go back to my code in my editor, make that change, push it up, and see what happens. I just have the fix right here. So that's our first feedback loop. And this is the same with like linting and all these things. My tooling is really great in this project that linting catches all of the styles that are important for my organization. And so if I wrote this whole thing in lowercase, it's going to come back and say, yo, you need to use camel case for your function names. Here's the fix. And now I can just hit go. And by the way, all of these agents that we talked about are in the repo itself. And I'll show where all the code is in a second, because it's really easy to do. It's not like I've built this super advanced rocket sciencey thing in my repo. It's really just the same kind of thing we do all day for CI/CD, but with a little sprinkle of AI magic in there to actually solve these things with agentic processes. So anyway, so that's agent number one has come in and said, here's the fix for your failing test.
And Kyle, there's a question.
Oh, sure.
On, where the agent is running in this scenario.
Yeah, good point. So yeah, let's jump away real quick. And so we're running all this stuff in GitHub Actions. And my test, for example, this is my test pipeline in GitHub Actions. And it runs the checks, and that's like the thing that runs test lint test build. And then in my Dagger functions for that check command that's running, we'll go here. So this is my Dagger code. It's in Go. And here's the check function that runs in CI. And then we run the lints for the front end and back end. And then if they fail, they run this debugger. And so this is just another Dagger function that is our agent. And it will, if we've set the GitHub token, which we do in our CI environment, then it will run that debug agent automatically when the tests fail. So go back and commit that suggestion on the PR. So that's where that agent runs, the one we just looked at. We'll see the other ones too. They're all in GitHub Actions though, all of them, because this is like Agentic CI. That's where we're running our CI. That's where our agents are going to run to.
Right. So if you're running, okay, so you're running your agent through GitHub Actions that launches Dagger, and then Dagger launches the LLM. How is the LLM getting started? Like, where's the LLM in this?
Yeah, so we can jump to this function. This is all just an agent I wrote with Dagger, and it's just connecting to whatever LLM I have anywhere. So in this case, it happens to be using Claude Sonnet 4, which is running on Anthropic's API. And in my Dagger code, I go up here and I say dag.llm, and I pass in whatever model I'm using and give it the prompts and the environment, and I get back the fixed test or lint. And so this is an agent in Dagger. We can go into more detail of how this actually built, but the main thing is, yeah, my models it's bring your own model. So in this case, I brought Claude Sonnet 4 from Anthropic's API. I could be running this in Bedrock. I could be running it in where, Olama locally, like wherever you want to be running your models. Dagger is just going to interact with it over the API and provide the tool calling layer to actually be able to edit code, run the tests, run the lints, all these things to actually make the changes to the code to try and fix the test, and then run the test to make sure that it's change that it thought would fix it actually works, and can you continue to iterate until we've confirmed that we've actually fixed the tests.
All right, so you're not using GitHub models, and basically from a GitHub point of view, the action launches the Dagger program, the Dagger binary, and that's all it knows it did. And then all the magic here is in here in Dagger. Okay, got it.
Yep. Yeah, and we can look at it. We'll look at it in a few minutes on the Dagger Cloud side, but you can see it in the GitHub Actions logs as well of like what's happening. It's all in GitHub Actions. The only thing happening outside of GitHub Actions is the actual LLM API. So my calls to Anthropic, but everything else is on my GitHub Actions runner. And then I saw one other question about like how that compares natively to like the CodePilot code review. And that's a good question because really what I'm talking about here is like a process change. It's not a specific tooling change. Like I'm not saying you should write a code review agent like I did here with this code to review your code. I'm saying any that automated code review is one part of the process change that needs to happen to help alleviate this bottleneck. By doing it this way, which we'll look at the reviewer agent in a minute, but like by doing it this way, I've been able to do a few extra things, which you wouldn't be able to do with a tool that's more disconnected from your actual agents and from your tooling. But it's a whole process change for CI/CD. It's not just like use Dagger, build this pipeline, and now your problems are solved. Any other questions before I cover the next part that we should talk about, do you think?
I'm looking through the questions. I mean, the other benefit really, sorry, is it Isaac? Isaac's asking around, why would you use this over a Copilot? And so one, not everyone has paid for that.
Yeah.
And two, you can do this locally, right? Like you can run this
Oh, yeah.
locally. You can run this in a different CI. You don't have to have CI to do this. You're just using GitHub Actions to run your program that happens to act like a CI loop. And yeah, because
Yeah.
I mean, being that I'm a GitHub Actions fan, I'm like, yeah, that's a great question. I would totally ask the same question.
Yeah. So Dagger, of course, runs locally the same as in CI. So this agent that I've built to actually debug tests and all the other agents we talked about, I can run locally. So if I'm working locally and my tests are failing, I can just run this Dagger call debug tests, and it's going to run that agent locally to fix my tests. So it doesn't have to run in GitHub. It's the workflow in GitHub Actions is just one way that it's triggered. But these are completely portable. Run them anywhere. The other question I saw that's good to point out here is like, does that mess up your metrics when the workflow fails? And so that's one very important reason of why I've done this test fixing as a code suggestion. One, so that the contributor can see, is that the correct fix? Or am I changing the test instead of the code? Or am I changing the code instead of the test, etc.? We want to make sure the contributor signs off on that change. But also, once it's contributed this suggestion, the test still fails, right? Because the current state of the code is failing tests. But now we've said this is the fix. When I commit this, it'll kick off a new run, and then that should the code should pass. So this metrics wise is the same as if the contributor got the test failure and then fixed it themselves and pushed it up.
Yeah, and there's actually some interest in seeing, following. I know you said you're going to show in a minute the Dagger Cloud view, but yeah, definitely interest in following that output to see the interaction with the LLM at some point.
Yeah, for sure. Yeah, I don't want to like put it off too long, but let's go through these, and then we can go through. We'll actually run the whole thing end to end real quick, and then see how it feels. So like, all right, so we've as the human contributor, I've got my code fixed. I asked for a review, and then the review bot it told me, all right, there's a broken test which we need to fix, and we have that suggestion above. And then we added a bunch of new stuff without tests, so you need to add tests for these new functions. And then it gives me some optional improvements if I'm like really want to go above and beyond, but the required improvements are like add the new test for your new endpoints. And so it gives me this little checklist, and now I can go back and forth with this as the contributor before a maintainer has to come in and tell me these same things. So that's case number one. We have agentic CI working with human contributors, but what about agentic contributors? So I mentioned I was using an agent here to develop this, but I'm pairing with the agent, right? So I'm me as a person, I'm fully responsible for this code that was submitted. But what about when there's no human on the other side of it? So we have this like sci-fi scenario that you mentioned earlier, Brett, where we just give an agent a GitHub issue and say, "Go fix it for me." So I'll go back to this issue real quick, and I say we want to do this the right way with an agent. I say add farewells to the API, and this is my description of the issue. It could probably be longer and maybe give more guidance, but this is realistic for how I might write a GitHub issue, because I assume that whoever's reading this can figure out the intent. And then I say /develop, which kicks off my developer agent. How does that happen? It's all just GitHub Actions, right? I'm a CI person. That's where CI is running. So I've got a /commands workflow. And when I say, let's see, /develop, this is a workflow that runs when issue comments are created. And in those issue comments, I look for /commands. So there are like GitHub Actions that kind of wrap this logic for you to make it easier, but you can do this out of the box with like core functionality from GitHub Actions. So I'm saying, all right, there was a comment. If it's not a pull request, so it's a GitHub issue, not a PR, and the comment body starts with or contains /develop, then we want to run this Dagger function. And that Dagger function is my develop agent. And I say, here's the issue ID, go figure it out. Also, here's an Anthropic API key. And so that's going to run our develop agent that solves it and opens a PR with a solution. And so we did /develop, and then we see agent Cal. That's the robot version of me. It's a GitHub app. It picked that up. It opened a PR, and here's its commit, solving the adding farewells. And so again, we got this thing to automatically run the test and all that, but because this is all connected within Dagger, the develop agent, once it submits that PR, can automatically say, okay, now it's time to hand off to the review agent, review my code in GitHub. And so this PR, see, I didn't type /develop anywhere. The review agent kicks off and says, cool, it's pretty good. You're calling this /random endpoint that doesn't actually exist, which is a very AI thing to do. And also you didn't update the docs. And so it got its review. Now, and this is where I said it's great if you have this tooling all in this platform where you can connect it all, because now the agent was able to request the review by itself. And then the review, once it posts its review, is able to actually give that feedback back to the agent and say, go fix it. And so then it was able to push up another commit. And if you look at this commit, it was able to add in its own rules file, right, its own prompt, make sure you always update the docs. So in its review, the reviewer said, you forgot to update the docs. Now the agent itself says, cool, I got this feedback. I want to make sure from now on, I never forget to update the docs. So I'm going to update my own prompt to say, make sure the docs are updated. And I'm going to add that to the developer documentation as well. Here's the new endpoints I added. So this is updating the docs. And then make sure that, just so all other developers know, make sure you update the docs. So it's updated not just for itself as an agent, but also all contributors. Cool. So it was able to self-improve with this flow. And the reason that's able to happen, if we just go to the code real quick, is because in that agent, if we go to the develop agent, so this is it created its PR, it's done, and now once it's created that pull request, it says, okay, give me that PR number, and then call pull request review. Pull request review happens. It goes through, it finds the GitHub issue, it reads the diff, it passes that off to an agent, and then says, cool, here's my review. This is the develop review agent that looks at that prompt we looked at with all the criteria. It puts that review as a comment, and now it says, if the author is Calbot, which again is like the agent that works in this repo, then let's pass that review back to the feedback agent and say, here's the feedback, go do the next iteration. And so the idea is, by automating this flow between the agents, now as the maintainer, when I show up on this pull request, it should be ready for me to look at. It's already had this review, it's implemented its feedback from the automated review. So now I don't have to think, okay, did it actually add docs? Did it actually write tests? Does this thing work? I can look at the solution as the reviewer and make sure that this is, my list of things to look at as a reviewer has shrunk, because the first feedback cycle has been done. Okay, so
Does it only do it once?
It only does it once.
Okay.
This is something like this is the toy demo version of this. I
Sure.
think they could go back and forth infinitely, or you could have some guardrails so you don't burn your money overnight.
Right. Yeah, you would need to have like a limit on that for sure. Yeah.
Exactly.
Back to the architecture, kind of the meta program that's running this.
Yeah. I mean, it's very much like agent view and IDEs, right? Like they all have a limit where they're like, we just tried 25 times and it failed, so we're going to stop and let a human figure it out.
Oh, so real quick, we're just gonna ask it to do something. We don't know what it's gonna do, but I'll say /develop and comment this. And so this is gonna kick off our developer agent, and we can watch it happen in Dagger Cloud because that's where we can best visualize all these agents working together. So if I go over to actions, that should have kicked off our create new endpoints issue being solved. And then we go down here, we see stuff happening. Looks like it's starting the Dagger engine. And now our session should be started. So if I go over to Dagger Cloud, all right, here it is. So we have the develop pull request functions running. I can bump this up a tick or two.
Nice.
And then it's loading, and then it's going to start thinking through this very open-ended issue we gave it. And maybe while it's starting up, we can look at the last one that ran, so you can see, so I can answer some of those questions that came through about how we're seeing these things happen in Dagger Cloud. So here's the last one that ran. This was for, let's see, the assignment was to add that farewell endpoint. So this is this PR that we were just looking at with the feedback loop involved. So this is our prompt that went in, including the assignments, and we can see it. We told it, go look at the developer docs, do all these things, and then we can see what the bot's going through as it's solving these problems. So it's said, okay, I have these tools to work with the code and test the code and do all these things. And as expected, it ran this tree function. And so now it can map it, hopefully, to those developer docs that we gave it and say, all right, here's the file paths. This is where these components are. And then let's see. So yeah, there's the developer documentation that it read. It just read the whole file. Sweet. And then it's exploring, poking around, figuring out where the tests are, what the code looks like. And then now it's done exploring. It said, cool, and it hasn't actually done anything yet, but it's making sure before it even starts that the tests are passing. So it can run this workspace check, and it's going to see, okay, everything's passing. So I know once I start changing things, if things are failing, I've messed up somewhere. So it's going to start by writing a new farewells JSON, because currently for the greetings, we have a greetings JSON. So it creates a new file of farewells. It looks at our main.go, and I'm guessing adds some new endpoints to return those farewells. Great. And then it updates the tests with tests for those farewells as well. So a bunch of new tests were added here in our tests, and then it runs the checks, and everything still passed. So this is where I can go to the one in a second that had the failure, but like this is where if things failed along the way, we'll see this happen in our logs over here as well. They'll be in the GitHub Actions logs too, of course, but this is constructed in a way that makes it much easier for us to read. Cool. So now it added the backend changes, and now it's going to do the front end changes. So it's going to write to our index.html. It's going to run the checks, and it says they're all good. And then let's see, it writes a PR name. So it calls out to another LLM to say, here's the changes I made, come up with a PR title for me. And then the title it came up with was add farewell endpoints with multi-language goodbye support, which is kind of a funny title, but it now has goodbye support. And then from there, so now it's submitted the pull request, and it kicks off that reviewer agent. And the reviewer has this prompt that we looked at earlier with the PR criteria. It has the PR description. it has the code diff of everything that's been done so far. And then it has this, I'm not sure what this last part is. It must be the changes in the website being rendered weird. But anyway, so it says, all right, let me poke around, read the changes, understand the diff, and then write my review. And this is the review that we saw posted in that comment. And now that takes that review, gives it to the feedback agent. And this is the prompt for the feedback agent, which remember has like the original issue that's trying to solve, as well as the code changes so far and the feedback. And so it gets this and then says, here's your feedback. And then it says, oh no, I need to add docs, right? So yeah, here we go. Oh no, I need to add docs and make sure to document to add docs next time. So it adds the documentation, pushes that up, and then at the very end, everything's passing. Awesome. So real quick, let me find the one from the failing tests. Let's see. It's in here somewhere. Maybe, oh yeah, obviously it's one of these failing ones. Okay, so our checks failed on a PR. And we can see in Dagger Cloud here that our backend lint failed with this this failure. We have one issue, and it's somewhere in these lint logs. This is like the exact problem we're trying to solve with creating agentic CI around this, because like I can scroll this and okay, here's on line 11 the actual issue with our linter, but like looking at this is all directly from my linter. None of this is anything that Dagger added. This is what my linter gave me. Like, what do I do with this, right? And like, obviously, you can poke around and find it, but wouldn't it be great if it could just fix it? So we saw that the linting failed, and remember in that code in our check function, if lint fails, it passes off to that debug agent, and then says, okay, the lints are failing, please fix it. And now it'll say, sweet, I'm on the job. It's going to run the test. It's going to get that same failure back to itself and say, okay, I need to change that. And it's going to write that diff, and it's going to say, cool, what is the actual diff? And then here's the diff. Remember, it changed that format response to format, or it added format response in addition to that greeting response. Okay, so here's the diff of what it changed to make the fix, right? So it poked around, it changed things, and then eventually it ran the checks again, and they passed. And so now it says, okay, I've successfully fixed it. Give me the diff of what I've done so far, and I'm going to comment that as a code suggestion on the PR, so that the contributor can accept the fix. But most importantly, at the end of that, I still fail because the state of the code at the current commit is failing. And so that's what we had on the Dagger Cloud side. We would see the same on the GitHub Actions logs. It would just be a lot harder to read because it's not nicely formatted like this.
Yeah, I wanted to highlight you dropped you said something very subtle early on, and if you're not someone who's like really into GitHub Actions and the difference between Actions and GitHub. Oh shoot! What's your robot running as? It's not. It's an app. GitHub app. Sorry.
Oh yeah, GitHub app.
Yeah.
Yes.
And how GitHub apps are this like GitHub apps are actually kind of weird because we don't see them in our Actions tab. We don't know. We can't look at the repo and easily tell that they're running that I'm aware of. And so you chose, for I'm sure certain good reasons, to have your AI code writer that's going to look at issues. It's choosing to use GitHub apps versus a GitHub action. Can you? And so that creates a new problem because now your actions and their logs are not necessarily correlated to the app and what it's doing. And so you had to use you had to use Dagger Cloud to correlate the work and the review, and then the work and the linting. You had to, that's where it comes all together because it's all in the back end running Dagger. But I was just curious, like, first off, why use an app there? Was there something that you need that, is it like cross repo permissions and all that that makes it easier with the app?
So there is a reason. There's a bunch of different reasons that you could use apps in this case. I'll show you exactly why. So first, like, yeah, we do have all the logs for everything in this stream, but as you can see, it's a bit harder to read than on
Sure.
Dagger Cloud. And so to get it in Dagger Cloud, all we had to do was actually in the GitHub workflow, in tests, we've added our Dagger Cloud token. So that's the one thing that ships the logs there. The reason I have my agents running as an app is because of this page that I reference probably weekly. It's this thing about GitHub Actions where for very smart reasons. All right, so let me take a step back. But by default, when you run,
Because security? I'm just gonna guess. Because security?
I mean, that's part of it. Yeah. So like by default, when you run a GitHub workflow, there is a default GitHub token in that workflow that has permissions to do a very limited number of things. And so for most cases, when you're doing CI/CD, you can use that token to go read content from your repo to do a bunch of different things, even to post comments on the PR. So that gets you very far. But one of the cool things that we saw is like when the bot opens a pull request, right? So this was, I stepped too far back.
So after you create the issue, and then the bot goes and actually writes code on its own, but it has to make a PR for it.
Exactly.
Yeah.
So this bot is the one that we did /develop, and it gets that issue and it opens a PR. And so if you use the default GitHub token to do that, and you check all the boxes in GitHub Actions to let the default token open a PR, what will happen is I'll get this PR, and that's it. Nothing else is going to happen. I'm not going to get this cool comment that happens when I open PRs. I'm not going to get my test running on this check because this PR was opened by me doing /develop on an issue. So that kicked off a workflow that then opened a GitHub thing. And by default, and this is why I opened this page, when I initiate an action in my repo that kicks off a workflow, if that workflow does any more actions on GitHub, that won't kick off more events in GitHub. It's not going to continuously cascade more events and more events. And they do that, one, probably to save their own resources, but two, to prevent infinite loops of these events going back and forth. And so there's kind of two ways to get around that. One, I can give the workflow a personal access token and say, act on behalf of me and do all these things as me. And that will let it kick off event after event. And I can manually give that token to every workflow that I want to continually kick off events. The problem with that is that now it looks like this pull request is opened by me. And maybe it does something dumb, and that makes me look foolish. Who knows, right?
Right.
Or, I'm going back.
You need to have deniability about the AI.
We need to say, actually, that was the bot that time, not me.
Yeah.
And so
so these are actually GitHub problems, like what you're talking about. Sorry to interrupt. I was just like, this is the nuances of working around GitHub's arbitrary limits. I was going to throw in that one of my big pet peeves is that workflows support cron, so you can schedule them, but eventually they will stop running automatically if your repo goes silent. Very annoying. Yeah. It makes it not a great place for GitHub Actions to be cron job like workload things unless you have bots, and you can work around all these limitations by having different things in GitHub doing different things to other things, but it feels very clunky. It's GitHub's fault. Let's all complain to GitHub. And I mean, like, if you're a paying customer, who cares if it's an infinite loop? Like, just do it.
Yeah, it's essentially it's an automation platform, and we as experts of that platform know how to open those doors, right? Yeah. And in this case, the best way for me was to use a GitHub bot or a GitHub app that in the workflow we're able to actually go use this. It's actually an elegant workaround to grab, by the way, a token. Yeah. Thank you. Yeah, it's had many different iterations.
Yeah. I can see why you would want to stick with GitHub Actions in all cases, because it brings things together. It keeps a seamless place. But if you have Dagger, then you at least have all of the metrics and the logs and the hotel all happening. Yeah, I mean,
that's why I kind of brought up that it's really just an automation platform, because we use this to run our tests and to run things on different Git events already today. And when you talk about agentic CI and doing AI related things in your code base, a CI platform is the perfect place to do those things because it's already just this event driven workflow engine connected to your repo. And so you don't have to use the built-in actions to just run tests. You can put your agent there and say, whenever I tag an issue, go solve it, right? It's an event system on your repo. You don't have to find some new platform to run AI things. Your CI can already do it.
Right. I should point out for you, like, to answer the question earlier, I can't remember who it was that asked it, but like, if you want to use the new Copilot review, I mean, this is brand new, I don't even think it's months old. The Copilot, like where you assign the issue to Copilot, you could have done that in lieu of your bot approach, and still have the Dagger workflow do the review. So you can mix and match this, right? Like you can
Absolutely, yeah.
As your team onboards GitHub Action Copilot functionality, if they so choose to do that, which is not free, then you could complement it with all the things. Of course, you can't run that locally. You can't run it outside of GitHub, but at least you have something that you could still work with. It's not like an all or nothing, I guess is my point.
Yeah, it's a framework for adding tools to solve problems, and in this case, I've shown a specific technology for those pieces of tools, but it's really, we're talking about the framework. So I've requested Copilot here. It will eventually put a review, and then here it is. So then again, that's just another repo event. I can have a workflow respond to that event and have my agent take in that feedback. And it's kind of cool because it actually kind of talked about the same feedback that their other agent gave. And let's see, it had that same thing about the slash random endpoint. So that's kind of fun. So we've recreated the Copilot agent in a few lines of code, but again, most of this is just creating the right prompts to look for the right things. And that's where we looked at this earlier.
It is cool to see in the Dagger Cloud. It's actually pretty cool to see it, the step by step of it work, like you would see in an IDE with agent mode in your VS Code or in your cursor. Like it shows you the step by step of its thinking and the tools it used, and that is pretty cool.
And clearly,
even if you could get that in GitHub Actions, it wouldn't be very good to look at. It would be painful to look at.
Yeah, I mean, and it feels like, right, as you look at this and as you make that connection, Brett, it does feel clear, and I think a lot of people are seeing in the future these coming together, right? IDEs dissolving into CI and local and various other compute providers. Like this stuff it's going to continue to morph and combine and recombine in interesting ways. So yeah, we're here for it. we're pretty we're happy to adapt. Right. But it is a lot, and it is coming. It keeps on coming.
And all of the code for the agents that I showed are in this repo, which I think was linked in the chat. But the main thing is, I'm not expecting anyone to go take these agents and use them. It's showing they're really simple to build, and you can also just pick agents off the shelf. But we're talking about a framework of how do you reduce the bottleneck for actually shipping code. And our proposed answer is put a bunch of these things in place that use better tooling. Like you need to up your documentation game, up your linting game, and then add some cool review flows in there so that by the time a maintainer comes to give the final stamp on a PR, you know that it's in a particular state.